Hello, everyone. Welcome to Colubrid and Colubroid Radio. I believe this is episode number 8. Zach here. Matt's here as well. How you doing, Matt?
Doing really good. Little covered in paint from some home improvement projects we've got going here, so our viewers can't see that right now. But, we made a commitment, and we're going to get this recorded finally.
Yes. It's been a little bit of an uphill battle. I think I posted on the Facebook page that we were going to be recording this right after Kathy, and it's at least 2.5, maybe 3 weeks since we talked to Kathy. But life shows up, and we didn't give up, and we're getting it done tonight. And this is a new kind of format for the podcast because we're back to me and Matt, and so tonight we're going to be discussing a topic that is very timely given the time of year. Don't know when you're listening to this, but it's mid-December. Right before Christmas. And the topic tonight is going to be brumation, because with colubrids, especially temperate colubrids, that's a super important part of breeding them in human care. But before we get to that, we have to do our typical just kind of update what's been going on lately. I guess I can go. My update is the semester, thank you, dear Lord, sweet baby Jesus, or whoever it is you worship, is over. This one was a bit brutal. This is my first semester as an administrator, and I appreciate being an administrator, but at the same time, the classroom is my church, and my happiest time was when I was there, not when I was doing whatever a chair does. But I figured it out, and those days are behind me. Well, they're actually not behind me. They're they're at the end of this break, too. But anyway, I get a little bit of a reprieve. So yeah, we're on break now. Things that I'm working on over my very small break. We don't have a long one this year. I got the book completely done. So the Dipsadded book has been written, edited again, edited when I thought it didn't need to be edited. And the written narrative part of the book is now complete. And then most importantly, the 200 plus citations in the book have all been formatted to spec. That's always the worst part, in my opinion, is making sure your bibliography is correct. I decided that if I'm going to write a book, I'm going to write the right way, and there are in-text citations all through this beast. So I am now using the break to hunt down photographs of as many of these snakes as I can, and I'm also trying to get habitat pictures and things of that nature. A couple people reached out to me, by the way, asking for those pictures. Once I make sure I'm allowed to give you the pictures from the people that took them, I'll be happy to let you see them. But my big thing for the break is going to be wrapping up this book and getting it as close to finished as possible. And of course, at this point, that's the photographs. And then collection-wise, everybody's sleeping except for my grow-outs. So it's kind of nice. This weather we've had lately has been insane. Last week, my Brumation corner, as it's called, I got a part of my garage that has a very convenient crack in the foundation that lets some cold air leak in. So I can hold that corner right at 50 degrees as long as the highs and lows outside are between 25 degrees and 45 degrees. And last week when it was up in the 70s in northern West Virginia, that kind of sucked. But it's really neat looking. I have govies all over the place in that corner to log the temps. And the Govee profile for December looked like it looked last March when I was pulling things out of Brumation. So, timely discussion. We'll talk about what that might do to the whole Brumation process here in a bit. But no, it's just baby time as far as the collection's concerned. All my little guys that I'm growing up, those are the animals that I'm working with now. So, lots of hognose snakes, Madagascar hogs, tricolor hogs. I really got into king snakes this year, so I got a lot of various locale Florida kings, and then a bunch of bull snakes that I picked up from Jennifer Joseph, who we had on as a guest. So that's what's been going on with me in the collection. I guess the other thing, because some people reached out to me about it, part of my job here at the university is I'm in charge of the zoo science major, and we've been working since May on a massive water monitor enclosure. And I'm happy to say that is done. That's been a lot of fun. Shout out to the West Liberty University maintenance guys that built it. But it's really cool to have an enclosure that's literally bigger than some of the rooms in my house for this lizard. So he's going to be living life to the fullest. He moves in there permanently in January. So if you're interested in seeing that, just go to my Instagram or my Facebook page and scroll down through and you'll see the videos, the progress videos that I've posted all year long. So that's what's new with me. What's new with you, Matt?
Well, fairly similar to yourself. I mean, most of my stuff is down for the winter, if you will. The temperatures and weather itself have been all over the place. Just like you, I have gobies all over my basement. But until we actually hit that frost, or to really kind of equate that basement for the temperature, I mean, I'm still right now around 62 to 61 degrees for most of those animals. It seems as though now with climate change, we're seeing what is just an extended fall.
Exactly.
For most parts. Which can make it a little bit interesting and difficult because you'll see some animals go off feed and then want to feed, especially with hatchlings. And that's something, from my customer base, I get emails or text messages all the time about, just in terms of, hey, my animal stopped feeding. And I think in our conversation, that's why we really wanted to do this type of podcast and discuss this, because it's something that a lot of people don't take to heart on how much barometric pressure, temperature changes, photo periods can really just kind of alter that animal's behavior. But for the most part, everything is down cooling except for, the file snakes, the Angolan pythons I picked up from Stan. Everything has just kind of been cycling normal. Work for myself has picked up a lot, which is why you and I have conversed on trying to reschedule things appropriately. Yep. I've been traveling a little bit more, so even for those people that have been texting or emailing me through Sarpamitra, I apologize about the delay, but I will get back to you. But I'm excited about this conversation because this brings back my academic days, and it really brings up some of the true heart of this hobby that a lot of us take for granted. So,
yeah, absolutely. Yeah, and one of the reasons why I wanted to jump in as well, with talking about brumation, is you see a lot on social media in the various groups that we all have a love-hate relationship with, where people will say something to the effect of, well, I bred those and they didn't, I didn't brumate them at all. Or you have some beginner will be asking, well, why do I need to do this? What's going on? Why are we brumating? And those individuals that get, especially temperate colubrids, which are colubrids that are basically halfway from the equator to the pole, or further north than that, if you get corn snakes or hogs or something like that to breed without you perceiving there to be a brumation, there was some kind of seasonal cue that caused those reproductive organs to cycle and to cause these hormone cascades we're about to talk about to kick into gear, because simply put, as you will learn, you can't ovulate without some of these cues. The females can't do it. So a lot of times by simply having, and Kathy talked about this on the last episode, by simply having your corn snakes, your hognose snakes in your bedroom where they have access to a window and they pick up the shortened daylight, that coupled with the fact that your house gets a little bit colder in the wintertime, that those two triggers might be all you need to get these things to go. But if you really keep them in an environment where it is the exact same temperature and you have 12 hours of light and darkness, if you have one of these temperate colubrids breeding, your animals are real special, because they have bucked evolution 100%. So,
well, and even to that point, as we get into multiple captive generations of animals, your first few generations of animals will require more cues. And that's something that, as we talk about this, I think will make more sense, especially when we talk about the biology that's actually happening here.
Yeah, absolutely. Because we are, in a weird roundabout way, domesticating corn snakes If you really think about it, that's what we're doing. And the domestication process involves removing nature and adding anthropogenic constituents to the mix. And so, that could explain how you might not have the extreme temperature swing and get the reproduction, but you still have some kind of temperature swing to initiate those hormone cascades, because it's just selective breeding. We're those animals that would normally be eliminated through nature, we keep them all. And so, yeah, we might, you might be reducing the impact of some of these triggers by maintaining everybody in the mix. But I guess we're going to jump in now. So the way we have this set up is we have an outline. We don't like outlines. We use outlines as just a means to make sure we hit certain topics. So we're gonna do this outline to a certain extent. But I thought one of the best areas to begin is oftentimes you'll see people discussing, is it hibernation or is it brumation? What's the difference? Is there a difference? Are they the same? And there's always that person. There's always that person who will kind of throw out there, well, brumation's just hibernation, so we shouldn't use that word. And then they get all upset, and we've got to deal with that. And there is an element of truth to that statement. So right off the bat, if you use the term hibernation for brumation, you are correct, because brumation is a form of hibernation in reptiles. Brumation was derived by a guy named Mayhew, who was a professor in California. And in 1965, he published a paper looking at the reproductive biology of Phrynosoma, which are horned lizards or horny toads, whatever you want to call them. And basically what he realized by looking at the impact of seasonality on these animals is that in the wintertime, even if he tried to keep them warm, there were cues that they were picking up from their environment that told them it was winter, and they essentially started to shut down physiologically. And so he, in the paper, Mayhew 1965, says, the term brumation is proposed to indicate winter dormancy in ectothermic vertebrates that demonstrate physiological changes which are independent of body temperature. So basically what he's getting at here is there's some kind of seasonal cue. It's telling them it's a season. That season would be winter in this case, and then that's causing a physiological change in the animal. So that's the definition, and then I'm gonna read straight from the paper. So this is Mayhew, the guy who came up with the term brumation. You can't get any better than this. He goes on to say this. Results to date, this is about the Phrynosoma. Results to date show that relatively complex physiological changes occur during or immediately preceding winter dormancy in some ectothermic vertebrates. To this extent, these animals are similar to hibernating birds and mammals. However, they differ from these heterotherms, which is the birds and mammals, in their inability to control their body temperature. Consequently, it seems advisable to have one term to designate winter dormancy in heterotherms and another for such ectotherms, that would be the cold-blooded lizards. Hibernation has been used to denote this condition in heterotherms particularly, so it seems best to retain this term for that group of vertebrates. Therefore, I propose this term brumation, from bruma, meaning winter, to indicate winter dormancy in ectothermic vertebrates that demonstrate physiological changes which are independent of body temperature. So basically what Mayhew was saying is a warm-blooded mammal or bird is going to undergo a different physiological change over winter than a cold-blooded lizard or snake, turtle, crocodilian, whatever, because of that physiological dichotomy between the two.
And that term is still brought up and still conversed and fought about in academics.
Yes.
And there's still no agreement on it.
Yeah.
Which is kind of the funny part. Because I think, what was it, Zach? Last year, I think one of the journals, they tried to refute and also just drop brumation from this topic with reptilia.
And the reason why that was done is it wasn't done because people didn't like Mayhew. Mayhew's very well respected for everything that he did with physiological ecology and field-based. he did a lot of field-based studies that are kind of considered classics in the field of physiological ecology. But it was basically that since Mayhew, this science advances, and the people that were saying we need to get rid of brumation provided evidence that it's essentially just to shut down physiologically through the winter. And there are certain hormones and things like that that need this process for them to be initiated and cascaded, and they're ultimately the hormones we're about to talk about that lead to reproduction. But that's the same thing that could be happening in mammals and birds. It's different but similar. So since it's different but similar, there's really no reason to honor brumation, so we should drop the term brumation and just use the word hibernation. But the way science works is until the entire field, 100% of physiological ecologists across the land, drop the term brumation, we can still use the term brumation. There's nothing wrong with using the term brumation. So it's kind of like in taxonomy, we talk about lumpers and splitters. The splitters would be the guys that are saying you are on team brumation, use that term, and the lumpers are going to be the people that are on team hibernation, use that term. So that's kind of the way it works. I mean, I describe new species of crayfish. That's what I do professionally, and I am a proud splitter. So fight me on that one. But I think Mayhew had the best of intentions. But you could just get away with hibernation, but there's really no harm done, in my opinion, with using the term brumation. And one of the things that led to the general populace picking up this, well, brumation may not exist, is there's a guy named Piker who has a really cool blog. It's old school, but it's great. And if you're a zoology nerd, go find this blog. It's wonderful. It's called Zoology Jottings. And Dr. Piker is, he's part of the Royal Society and over in England, and well-known zoologist. He is on team kill brumation. And right from the blog that was shared all over Facebook, this is coming straight from that, his argument for getting rid of the term is that, in summary, brumation, 1, is unnecessary since it has no explanatory value, 2, can possibly be positively misleading when applied indiscriminately, and 3, time, therefore, for the term to join the dead parrot in the choir invisible. So, that's pretty damn dramatic. I think what he's getting at here can possibly be positively misleading is this idea that the cold-blooded animals are undergoing a different physiological state than the warm-blooded animals when they're both just basically undergoing a winter-induced torpor. So, even though I just said I was on team brumation, I totally can acknowledge that that's a valid point. So, the reality is I care, but it is what it is. You have thoughts on that?
No, I'm in the same boat here. Because over the time, even in the academic sector, I had brought this up before, and I always used to get a lot of slack too as well by using the term brumation versus hibernation. And one of the more interesting parts too as well that I find is I collect books, and reading through prior writings, there's so much that we take for granted of current science and how we can actually take that science and look at it and see how we're progressing in the future. And it is very likely that as we discover more and look at physiological changes, chemical changes, I think that there's a lot that can be said to keeping the term, but applying it more specific to the terminology for cold-blooded animals, if you will. It's just our knowledge base for this isn't completely straightforward. We've kind of lumped it, left it at that, and not really exploited everything that's there.
Yeah. And in all actuality, physiologically, the way a cold-blooded animal operates and the way a warm-blooded animal operates, without getting into hardcore physiology speak, it is different. So it's basically a potato. I think one way to look at it is the people that are on the side of hibernation might be saying, from a broad sense, that all these vertebrates are undergoing a dormancy period in the wintertime that do this because of the environment they find themselves in. So they have to, like, snakes cannot slither across the snow and find a rodent, constrict it, eat it, and digest it at that time period. And then certain mammals just simply can't be out in the Arctic tundra in the middle of, like, when there's no ability for them to acquire food. So they're kind of viewing it from an ecological lens, whereas the people that are on Team Brumation might be viewing it more through a physiological lens, because they're basically saying that the inner workings of how the animal operates are going to be different between a mammal and a reptile, fish, amphibian. So because they are different, we should basically say they have two different terms. And if you've got a situation like that, that's why I say pick a term and run with it and just be okay. But there's just not a need for people to flex on social media and be like, you said brumation, it's really hibernation, and now I'm going to shut you down with these 4 paragraphs of all I know. Because that's just, just why. I know so many people that know far more about everything than me that are incredibly humble, and I look up to them because I know they're not going to flame me. I know I can go to them, and I know I can learn. If you're that keyboard warrior throwing that out there, you're just basically trying to show everybody what you know. And that doesn't, why? Why do we need to do that? End rant right there.
Yep. It's a good way to end that one. Uh-huh. But even the way these two different groups of animals prepare for brumation or hibernation is very unique and different. Because even with humans, there are external cues too as well for us that we experience during this point in time. But when you look at reptiles and mammals and look at gut flora, fat storages, the fat storage really isn't critical for reptilia going into brumation, which is something I've always found very interesting in terms of the way that people progress and say, well, I really need to stock up my animal getting ready to pursue hibernation or brumation, because unfortunately that animal isn't necessarily burning fat in the same way that a mammal does either.
Yeah, what you are doing is you are preparing its future eggs if it's a female for this process called vitellogenesis. We're certainly not putting on a layer of fat to protect them through the wintertime. That's not what you're at. Yeah, that's not what's going on there. So,
but I guess before we go too far down that road, because that is an interesting biological point of brumation, probably be good to just go into what exactly is going on. And why is brumation important for reptilia?
Yep. So what's going on with brumation, and we're going to use the term brumation just because it's the standard term that we're all used to. And if I correct myself every time I say brumation through this podcast, it's going to be clunky as hell. So we're just going to go with brumation. But brumation is very important to the animals for a couple major biological functions. First, the obvious, it's wintertime, it's cold. These animals in particular they're literally not able to function. So when the temperature in Fahrenheit, it's 50 degrees. In centigrade, I think that corresponds to roughly 10 degrees C. That's kind of the magic threshold. Somebody asked, what is the temperature we're shooting for? I think that was Clint. Yeah. And why do we shoot for that temperature? People have done, physiological ecologists have done all kinds of studies looking at gut enzymes, hormone production, melatonin production, all these things that animals use to maintain what's called a dial period, a 24-hour activity period. So things that tell you it's time to wake up, it's time to go to bed, it's the middle of the day, it's time to go find food, I'm thirsty, it's time to go find water. All those kind of cascades and triggers and mechanisms physiologically happen above that temperature. When most, not all, and that's another thing, when we're doing this podcast tonight, it's most. Even if I say all, I mean most. There's over 2,500 species of snakes, peeps. So anyway, most of these animals, when they hit the 50-degree threshold, you lose digestive enzyme production, the lining, the mucosa of the stomach, the mitosis that keeps that alive and functioning, that goes away. The intestines will stop absorbing water because physiologically these animals are basically going to go down to close to zero. Now, one thing that's kind of interesting is, and I'm recording this in Arnett Hall. I have garter snakes in our cold room right now. That cold room holds at 46 degrees Fahrenheit. When mammals are hibernating, there's no movement. Like if you look at the ground squirrels that are famous for this, they look like they're in a coma. Like you can't wake them up. When I go and do my once every 3-week brumation checks and I open up the lid, the garter snakes very slowly turn their heads up and look at me. So there's still some brain activity there and they're aware of their surroundings, but at the same time, they're just not moving much. So it's really kind of an epic state of torpor is the way that you want to think about it. But physiologically, a lot of these functions stop. And that's why getting the animals to 50 matters. That's not like an arbitrary temperature. That is a temperature we know physiologically shuts down these processes. If you're holding your animals at like 60 to 65 degrees, depending on the species, that could shut them down. So if you've got something from like an Everglades rat snake from extreme southern Florida, 60 degrees might be necessary to cause brumation to be induced. But if you have fox snakes from Minnesota or Wisconsin, you got to get those animals down below 60 because to them, 60 is warm. That's the temperature that they're coming out and mating at. And if you're only getting them to 60, all those things we're talking about, those enzymes, the brain function, the mucosal line, all that stuff's still happening, it's still active. And so if you're going to induce the brumative state, which is the winter-induced torpor, got to get them down to that temperature. The other thing that's happening is there's a lot of evidence that the combination of darkness and low temperature, not just low temperature per se, but darkness and low temperature, though that's what leads to certain hormone production ceasing, and it's the shutting down of the hormones initially in the fall when you're going from warm to cold, and then the duration of darkness and cold, coupled with the endpoint of warming up and light. That kind of chronology needs to happen for many temperate colubrids to think, oh, it's mating season. If you don't have that order of events, you are not necessarily going to get courtship behavior post-winter. And what's actually happening there is the production of a whole bunch of really specific reproductive hormones. And these reproductive hormones are different in the boys and the girls. And what's controlling them is different in the boys and the girls. So snakes that are actively brumating, that's what's happening and needed. In the boys, you need it to basically keep the sperm alive for some of them because they go into brumation with the sperm ready to go. For other species, the sperm are starting to get ready when they're going into brumation. And then that cooling coupled with the warming is what ends spermatogenesis, the process of making sperm. And in the case of the females, this order of events thermally is what leads to follicle development. And then you develop the follicles, you then yolk the follicles up with vitellogenesis, and then obviously the combination of this happening in boys and girls at the same time of year with these triggers is what leads to ultimate courtship and mate. So that's what's happening with our temperate guys. But before we jump into that, I thought it was necessary to talk about what the hell happens in like the tropics or the subtropics. Like, do you need to brumate tropical snakes? And in this situation, the term brumation is interesting. So I have a lot of South American dipsadded snakes. Kind of wrote a book about them. I'm obsessed with them. And they are very different. Very, very different than corn snakes, rat snakes, milk snakes, fox snakes, gopher snake, like all these temperate guys, in that they are what are referred to as continuous breeders. So, in theory, they are ready to mate any time of year. And false water cobras are not just my favorite snake, but the best example, in my opinion, of a continuous breeder. Because if you take a male false water cobra and you put him with a female this time of year, which I actually did last week, he's going to court and copulate with the female. And if you take that same falsie and put them together with a female in April, July, September, doesn't matter, they're going to mate. Why are they going to mate? Because they're continuous breeders. And in these animals, they do experience a seasonality. The seasonality is, instead of the nighttime low being 78, it's 60. But if you mimic that, for a couple months, you actually get higher production in my experience. So I didn't brumate false water cobras. People don't talk about brumating them. And I got clutches out of these females that were numbering around 15-ish eggs. The same girls, just 1 year later, gave them a 2-month period of time where all I did is I unplugged the thermostats. They have heat panels, same light levels. They went to room temperature versus having a higher daytime temp, mimicking that wet season that happens in Paraguay where things get a little bit cooler. And my egg production increased dramatically. The same females that were dropping 15 eggs were now dropping 25. And one of them is now, she hasn't crossed the 30 mark. She's gotten to 29 twice. So there's something going on there, in my opinion, because this isn't just one female, this is two. And that's not a huge sample size, but in a perfect world, I would be breeding 30 water cobras. I also would end up with, Jesus Christ, way too many baby water cobras. But so there is a seasonality in a brumation. Sometimes people call it a soft brumation. That does occur with these tropical / subtropical snakes.
Well, and even going into this a little bit deeper, I do find, having worked with a number of species that not many people have worked with, that certain animals will breed better in different geographical locations.
Mm-hmm.
And part of that is entirely to the point of what you just brought up, based on barometric pressure, light cycles, because those animals are going to respond to those cues,
yep,
respectively. And while they're not going into a full brumation, you will see animals, house snakes, for instance, they'll go off feed. And they're going off feed because of those cues that they're actually picking up and feeling from some of these changes. And a lot of those changes are just hormonal based for the response of the animal.
Absolutely. And another thing that you see with these continuous breeders is that there's a whole lot of sperm retention. So they basically have evolved mechanisms where they mate, and you end up getting a clutch like 4 to 6 months after they breed. And you think, what the hell's going on here? And then you don't put the male back in there, and 4 months later you get another clutch, and then you get another clutch. These South American dipsadids do this all the time. This is part of their life cycle, being continuous breeders. Basically what happens is, since they don't necessarily have an inactivity period, is that when a male bumps into a female, he's going to mate with her. That's just the way that their life history has evolved. And the females in that situation have mechanisms to store sperm. And they store it, and this will be another podcast another day. But there are multiple places in a female's reproductive tract where they will store that sperm. And then basically, this is done so that the female goes off. She might end up going into the wet season when there's going to be an abundance of amphibians, and she mated during the dry season. And then she'll ovulate with those barometric pressure cues you're talking about, produce a clutch, and then the clutch of eggs, hatches at the end of this wet season when there's buku amphibians for the baby snakes to eat. Like that's not an accident. Or, which is what happens with false water cobras all the time, personal experience here, the females will mate, they'll lay a clutch, and then if they get a lot of food after laying that initial clutch, they still have active sperm in their reproductive tract. They will then double clutch. If you are, most false water cobra breeders can attest to the fact that if you get your animals back to weight, you do not have to introduce a male. They're going to drop another clutch of eggs. It's just, it's happened with me the past 3 years. So, but that's nature, because out in South America, they may have in the Chaco where these animals live, it might be really dry and the females lay their initial clutch. They don't get the resources they need to yolk up another clutch of eggs. So that year they only lay one clutch of eggs. The next year might be a wet year. Because it's wet, the resources are high. The snakes are eating a lot more. They've got the fat that they need to yolk up eggs. And then boom, they have the ability to ovulate. Little baby snakes are dying like crazy out in nature. Everything eats them. So if you're trying to get your genes in the next generation, it makes a whole lot of sense to get as many copies of your genes out there as possible. So double clutching in this situation, not the big a deal. So what you see is in these animals that don't brumate, they're also the animals that oftentimes naturally will double clutch. And when you have them in human care and they get a rat every week, you're just begging that process to happen.
Well, and that physiological change, if you will, it's not something we need to enforce before cooling the animals. And it's already been proven and written about that reptilia will store sperm as long as they're well fed, which really comes into, and not to dive too far, but preparing animals for breeding, it's really when you're starting to pair animals that you want to make sure that your animals are being well fed. And by well fed, it's the females, because we want to make sure that they have those fat deposits ready and available for oviproduction.
Yep, 100%. So that's what's going on in the tropics. Let's head back north or south to our temperate latitudes. So what's going on there? So there is a easy to find PDF written by the lead author of it's Dr. Emily Taylor. A lot of people are aware of Dr. Taylor. She did a podcast on the Pingle Field Herping podcast. I think her Twitter handle's like Snaky Mama or something like that. But she's a professor at in California, and she's fantastic. She does a lot of research on with rattlesnakes, and I'm actually working with her with one of my current graduate students, Aaron, on rattlesnake relationships with humans and trying to get people to care about them. So it's kind of a com-bio perspective. But she wrote a review paper or chapter many moons ago, and the title of it is Hormones and Reproductive Cycles in Snakes. If you go to Google and you type that in and you follow it with the word with PDF, you can get this. It's readily available right off the internet. And it's a little dense, but the rest of tonight is coming just basically out of this review paper. And it's a little bit old, but that doesn't mean it's bad. It's really good at like laying the foundation of what exactly is going on with hormones, reproductive cycles, and the environment controlling all of this. So back in the early 80s, there were two terms that were utilized to describe the reproductive cycle of it focused mostly on males, with snakes in general. This isn't colubrid centric, but some of the animals that were looked at intensively to come up with these terms were garter snakes, red-sided garter snakes out of Canada. They don't know if it's Sertalis, Parietalis. They're like the gold standard for snake reproductive studies and physiology. If you're a garter breeder, you got it set, because you can literally read hundreds of pages on this stuff, and it's directly applicable to you producing your animals. So with that being said, this isn't really coming straight from the world of rat snakes and milk snakes, bull snakes, gopher snakes, things like that, but it's absolutely applicable. And so in one of these early publications, two terms were proposed. One is what is referred to as estival. And in estival breeding animals, sperm is produced over the summer. And so basically what happens is the animals come out of brumation and they have not produced sperm. And then well, let me back that. That's incorrect. The animals go after the mating season, immediately start the production of sperm. The sperm is then in the testes, ready to go. And then they go into brumation with their testes and sperm right there, so that when they come out of brumation, they're right there, ready to go. But the main production of sperm occurs over the summer. With vernal, which is the other type, spermatogenesis occurs in the fall. It's completed by early spring. And so you don't have it being prepped during the summertime, but rather you need that kind of temperature / light change in the fall to tell the animals it's winter, we're heading into winter, and that's what triggers spermatogenesis. So day length has something to do with this whole thing, and temperature has something to do with this thing. And these two strategies are directly applicable to the snakes that we have right now. So what actually happens in most snakes is a mixture of the two. So the best way to view these two terms is to basically view them as a continuum. Not to try to put snakes into the estival container and the vernal container, because biology, I tell my students at West Liberty all the time. And evolution does not like absolutes. That's not the way this works. It literally doesn't work that way, because the beauty of evolution is variation of population. So, with that being said, you also get a lot of mixed type systems, and that's what they're referred to. And this is when you have mating in the spring and fall. And so if you think about the snakes that we have, I know garter snakes will readily have a breeding season right coming out of brumation, and then you're going into the fall, and they're ready to go then. Well, you've got estival elements and vernal elements in those. My Japanese rat snakes are a great example of this. So I did something that many people would consider blasphemous. I kept all my Japanese rat snakes together in one vivarium this year. It was a 6-foot-long cage in my garage, a 6x2x2, and I decked it out with branches and hide boxes. And the males went nuts and bred the females in the spring, like you would expect. And what was really interesting is, as soon as the temps started dropping in the garage, I would go out and check my animals every night, and I got a second courting period. And I decided, what the hell? I'm just going to let them go. And if they inseminate the females, they're ready to go as soon as they ovulate coming out of springtime. That's an example of a mixed type system. So, yeah, that's kind of how this works. And the main driver of the sperm production is going to be the testosterone levels. So what happens is the snakes come out of brumation. They're picking up photoperiod, which in the temperate latitude, days get longer going into springtime, summer. And then you get to summer, that's when you're at your zenith for light. And then once you hit, it's June 21st through September 21st, you're losing daylight. On September 21st, you got 12 hours of daylight. Sorry, you got a lot of daylight then. September 21st, 12 hours of light, 12 hours of darkness, and then you're going into what was literally, what was that, yesterday? I think it's December 22nd, yeah. December 21st, which is the winter solstice, when things are as dark as they could be. That photo period is hitting their retinas, and it's telling their brains what time of year it is, and then that's directly being converted with their testes in this testosterone production. So this is why, if you keep your snakes in enclosures with 12 hours of light, 12 hours of dark all the time, you're not going to get, you might see a lack of sperm production in your males. Or it might not impact them at all. It just depends on the animal.
Well, and not only that, temperature is such a critical part of this, where if you are keeping your animals too warm or they're not able to escape from periods of warm, you could be destroying the sperm itself. And that's something, especially over the years, I've really started to keep my animals cooler than what they're typically held at or written about and published in terms of temperature zones. And I think that does have a very big importance, especially with the retention of sperm as well as sperm strength when cycling animals.
Yep. So if and the thing that sucks about sperm is that you're right, it does not do well at high temperatures. So you can absolutely, if you're keeping these temperate snakes and they can't get warm, you're basically nuking their testes, and there's not going to be any successful mating at all. So with this estival vernal stuff, they came up with some other terms for it, and I like these terms a little bit better because they kind of tell you what's going on. So with the estival, that's where the sperm production is occurring over the summer. You get this production of sperm after mating, and so that's what we refer to as a post-nuptial system or disassociated system. And with a vernal, these are the animals that the production of the sperm happens in the fall, right before mating. They're what we refer to as prenuptial. So basically, that fall, going into fall into winter, triggers the testosterone to go up, and then the production of the sperm through spermatogenesis. There we go. So this is where knowing the biology of your snake matters, because if you understand what mating system it has, that might actually be a good way to get these things to breed. And a lot of times, colubrids, you don't have to know all this stuff. You certainly don't have to know the difference between estival and vernal to breed a corn snake. I just think knowing this stuff makes them a little bit more interesting. And it also explains why you got to cool them and why you got to keep them warm. So, that's males. Do you have any experiences breeding all the 355 colubrids you've bred?
Well, it's interesting on some of these in terms of that, because depending on some of the species, you do see this mixed level becoming more towards fossorial species, I would say. And I think that has to do a lot with just light cycles, but also their cryptic nature. Archolaphae, for instance, they'll breed through the brumation period, and then the females will actually come out and ovulate, producing good ova. The same is true too as well with green bush rat snakes, Porcinum, and they'll breed throughout the entire year. So they have that mixed cycle. And some of that, I'm sure, is evolutionarily dependent too as well on food sources throughout the year for those animals. And those adaptations have just proven a strong point, especially in fossorial species, to escape heat or extreme cold, to create more lucrative nature for the sperm to actually be at its highest point for fertilization of ova.
That's pretty cool. I didn't know that anybody bred during brumation. That's really interesting.
So you have to start to think too, with Amnophis. I mean, most of our keeping, we don't pair animals throughout the whole year. I actually like to keep animals in communal settings, depending on the species, depending on their behavior. But for some new species, we could also be missing key points of their ovulation cycle by not having them in the appropriate time for where sperm is at its strongest. Or, depending on the animal, it could be potentially possible that during brumation is when that animal actually is required to breed and hold the sperm through that early part of spring or when they come out. That's one of the interesting parts of the hobby, is we're able to use our observations from someone that might not have those observations as a field scientist and grab that information and provide it jointly. And that's a key part in this whole observation and keeping records. Something I thought that was very interesting, even in our conversation with Chaz, with providing diaries, because there's so much that can be told here too as well with food cycling. Some people will food cycle animals.
Yeah, and we can hit on food cycling a little bit, because that's like a gold standard part of reproductive husbandry for pythons and boas. The Boyd people are always talking about that, and it makes a tremendous amount of sense, because these animals are coming from the tropics and they are getting seasonal cues, but the cues are not the same as what's happening at the temperate latitudes we're talking about, and it totally has to do with a boom bust cycle. In the case of the cycle feeding, the boom bust is the food. In the case of the temperate colubrids, the boom bust is the temperature. You have a boom of temperature in the summertime where everything is warm and conducive to physiological state, and then you have a bust of temperature during the wintertime when they can't do anything because it's deadly to them outside. So they still figure out a way physiologically to utilize this time for part of their annual life history. But with colubrids, I know of a couple groups where people will talk about cycle feeding, but you don't really hear a lot of people discussing cycle feeding with, our snakes. I know I've heard some Spilotes discussions about hitting them really hard coming out of the springtime, and they'll reproduce. I've heard some of this with the Drymarkin, not necessarily the Eastern Indigos, but the Crebos, the blacktail Crebos, yellowtail Crebos. But like, what about Musaranas? What about false water cobras? I actually do, now that I think about it, hit them real hard in the fall before I induce a brumation period. Maybe that's what caused all this reproductive success I had, and it had nothing to do with temperature. I'll totally own that. That's a possibility. I guess now I just came up with an experiment literally while we're recording this, so I won't cycle feed them next year, and we'll see if the production's the same, and then I'll find out it has nothing to do with the temperature. Anyway, but that's scientific keeping, and that's the way I want to keep. Like, that's fun to me. Like, you're advancing this discipline when you do things like that. So, all right. So let's talk about what's going on with females, because I'll fully admit I went down a rabbit hole, caught the rabbit, fed it to a snake. Getting ready for this episode, and realized that there's a lot of really cool things going on that brumation induces that leads to reproduction. So like this coming out of cooling, why do the snakes reproduce then and they don't reproduce? Well, with their temperate colubrids, what happens during the cooling cycle is it's important for the production of certain hormones in female snakes and the disproduction. So like basically the snakes get a trigger that tells them, I'm not going to make this hormone when they get cold. And there's 3 hormones that are real important in the maintenance of eggs through the reproductive cycle of a snake, based off the review that Taylor and I forget the other author on that. It was Taylor and DiNardo wrote. And so these hormones, let's just go over the hormones really quick. The first hormone is called DHT, and DHT is dihydrotestosterone. And what's interesting about DHT is it's what we call an androgen. Androgen are hormones that are based off testosterone, and that is indicating male. So we have DHT, testosterone-based hormone, and then we have another hormone called estradiol, estrogen. Estradiol is a female-based hormone, and estradiol is extremely important in snakes for vitellogenesis. So basically, the yolking up of eggs, the taking all that fat that they put in their fat bodies, and then estradiol hits. There's a bunch of physiology we're not going to talk about that then is able to harness some of that energy from the fat and then convert it in towards the follicles that are ultimately fertilized. Once they're fertilized, we have to basically bulk them up, and that's when we get vitellogen, and vitellogenesis is occurring. And then the final hormone is a hormone we call progesterone. And progesterone is another female hormone, and it is basically a hormone that shows up and is oftentimes associated with the maintenance of pregnancy. So in this case, it would be the maintenance of the egg, of the clutch, but it's most important in things like water snakes, garter snakes, are live-bearing snakes. And so if you take blood out of female snakes during every month of the year, and you look at the levels of these different hormones, there's different months where the different hormones are peaking. So when you come out of brumation and you enter courtship, that's when the DHT levels in the blood are really high. Estradiol is starting to get high, and progesterone levels are very low. If you get a successful mating, so basically copulation occurs, we get a fertilization internally, and we're now yolking up eggs, what happens then during that yolking up of fertilized eggs, or the basically production of eggs that are going to ultimately be laid? This could also include infertile eggs. That's when DHT levels plummet and estradiol levels start to peak. So you get estradiol levels during the gestation / ovulation / fertilization / getting the eggs ready to go. And then what ends up happening is once you get past that time period of the reproductive period, estradiol plummets, and then progesterone slowly but surely increases throughout the duration of the pregnancy, and it's going to reach its peak right before parturition, which is biological speak for laying or having babies, okay, or laying eggs. And so you have this interplay of these three hormones, and there's different times in the reproductive period of a snake where these hormone levels are going to be peaking. And so Kevin Saunders asked us a question: is there a way to like tell if brumation worked? It's not cheap. It's fairly intrusive, but if you were to grab a snake and take blood out of it, in theory, you could look for these various levels, and you would expect the DHT levels to be very high in the snakes post-brumation when they're getting ready to copulate. Because the other thing that happens with brumation is when the animals come out, there's that, and we all know this that have bred snakes, there's that like week to 10-day period where they're kind of like groggy, they're getting back in the swing of things. Well, during that period, your DHT levels are going to be in some species growing, getting ready for ovulation. In some species, they come out of brumation, DHT levels are going to be really high. And unfortunately, there's been so little reproductive biology done on colubrid snakes that we don't know, really, what species have what levels at what point in their reproductive cycle. But you need the brumation process to initiate all this. And if you don't have these reproductive hormones being produced in this cascade, then you're not going to get eggs. And so this is, once again, where having them in complete darkness and cold is what prepares this series of hormones to happen. If you keep your snakes at 12 hours light, 12 hours dark, and at 75 to 80 degrees year-round, and they're in a basement where they're not going to pick up any kind of light cues, and the temperature is relatively constant, in theory, you should not get reproduction in a temperate colubrid. Because this is what's happening inside the females this is the hormones that we're talking about that are so important. So it's pretty cool. And this is all explained in that manuscript that I talked about. And the different hormones have different purposes. So DHT, the first hormone, it's an antagonist to a lot of the female hormones. So basically, it is a hormone that is pre-ovulatory, and it's letting the females know, don't get your eggs ready yet. Don't get your eggs ready yet. Don't get your eggs ready yet. That's what you're going to have during the brumation period. And then when they do the warm-up, during that warm-up, there's a physiological change that you get the DHT levels start to drop, and the drop of the DHT is what initiates the increase of estradiol, the next hormone. And estradiol is the hormone that's responsible for telling the females, okay, we're getting ready. It's time to go. Reproduction's about to happen. So your DHT level's going down, your estradiol level's going up. That's what you might have if you pull your snakes out mid-March. That's happening end of March, beginning of April. That's what's actually happening inside the animals. The progesterone serves a really cool effect because it's the hormone that kicks in that says we're getting ready to lay eggs. But there's some evidence, especially in these temperate colubrids, that may not have the time to double clutch. That falsie down in Paraguay's got all the time in the world. A fox snake in northern Minnesota does not have all the time in the world. It produces a second clutch. It may die. Well, progesterone levels have been shown as they elevate, they also can be inhibitory towards ovulation. So you actually want that spike in the progesterone levels to basically say, okay, let's stop. It's time to end this. So that's, so there's a lot of really badass biology going on in the snakes that some of you have currently in the corner of your garage where the crack in your foundation is, where all 75 colubrids I have resting in my garage. Like, that's the stuff that makes me nerd out. It's just thinking about all this. This is why they're down there.
Well, and this is like one of the coolest parts too, because there hasn't really been much in terms of publications on these hormones as they play to infertility with infertile eggs or just ova being laid. And, you have to think about this as a complete recipe for success. Yep. So if you are off one of your cues, you could be inhibiting the production of one of these hormones for egg binding, bad eggs, or just animals not showing any interest in terms of breeding.
Absolutely. 100%. And there's also stuff outside of the endocrine system. There's stuff that's going on inside the brain during pre-brumation, brumation, post-brumation that's telling these temperate colubrid and colubroids, okay, I'm going into winter, I'm coming out of winter. If I'm coming out of winter, it's time to mate. Because the reason why they mate, we haven't really even gone over this. There's two real good reasons as to why they're mating when these animals are mating, which is usually within a month of leaving the den or the hibernacula, or immediately upon leaving the hibernacula. And one of the main reasons is hibernacula are rare. A hibernacula is where that's the technical term we use for where the animals are overwintering. And there's an extremely specific microclimate and microhabitat that these animals need for a hibernacula to work. The hibernacula needs to be below the frost line, and it needs to be in a situation where it's going to hold at that magic temperature of 40 to 50 degrees, and it's not going to drop below freezing for extremely extended periods of time. And if you think about that, that's kind of a really special microhabitat in a sea of habitat where that's not present. So because that's a limited feature on the landscape, you end up getting aggregations of these snakes. That's why the myth of the pilot black snake came to be. That's one that's here in Appalachia. The idea is that black rat snakes lead timber rattlesnakes and copperheads to a crack in a rock wall. Well, that's not what's really going on. Black rats are one of the first snakes to enter hibernation. The pit vipers are kind of second, and they have to share that hibernacula because there's only one in 100 acres. So you end up getting all these species together. Well, if they're all together and they got a limited amount of time when they come out of that hibernacula, you've got basically spring, summer to get your babies out. You want to be making sure that you have your young before fall hits, because you want the young to hopefully get a meal or two in them before they enter hibernation. Then you have a limited amount of time to get all this done. So the fact that everyone's together in the hibernacula makes a whole lot of sense that when you come out of that, you're already together. Just mate. And so a lot of these animals mate immediately upon leaving the hibernacula, or they might leave the hibernacula, stay, in maybe a 50 to 100-yard square area around the hibernacula. They're moving, scent trails are being laid down, receptive females are letting out their pheromones, they're telling the boys where they're at, and then they mate, and then they disperse. But it's still all based around this one space. And that's probably due to these winter aggregations. Like that's good evolutionary biology that we have going on there. But what's going on outside of the hormones is there's literally triggers inside the animal's brains. And the triggers that are in the brain have a lot to do with photoperiod. So we haven't talked about photoperiod much. We've talked about temperatures and getting things down, but why do you need to hibernate them, in darkness? Now, there have been some studies, before I go any further, that people literally tested which of the two is more important. Is hydroperiod, wrong thing. Is thermoperiod more important, like getting them down low temperature and having some light? Or is it keeping them in perpetual darkness and not getting them down to temperature? And if you have to choose between the two, temperature is more important. In all the studies that have done this with garter snakes in particular, they've always shown you got to get them down to temperature. If you don't get them down to temperature, it's not going to be good. But if you get them down to temperature and you don't have photoperiod there, you won't get 100% reproductive success. And the reason for this is that activity levels in the brain differ between females and males during brumation. And the part of the brain that's being impacted by that's causing these is the hypothalamus, or the APOA, and that's a portion of your brain that's real important in the maintenance of hormones. and things like that. And one of the things that was found is this is an area where hypothalamic activity is different between boys and girls. So male snakes, there's not really a major difference between the activity of the hypothalamus. But in female snakes, you see a huge dichotomy in hypothalamic activity during brumation and outside of brumation. And this also is going to correspond to everybody's favorite organ or gland, the thyroid gland. Here, my family suffers from hypothyroidism. That's when your thyroid gland doesn't produce enough thyroxine, which is one of the hormones. Thyroxine is a major endocrine stabilizing hormone. It's one of the hormones that controls your metabolism. If you're not producing enough thyroxine, you don't metabolize food very much. If you produce too much thyroxine, that's when you're hypothyroid, and that's the person that has to eat every 5 hours, or they get hangry, and then they're still like skinny as a rail. So the thyroid gland has a lot to do with hypothalamus and all this. And what ends up happening here is that when a snake is cold, thyroxine production is going to be very low. When a snake is warm, thyroxine production is going to be very high. So in males, with an increase of thyroxine following the warm-up over a long cold spell, this is what's going to lead to them basically knowing, oh, it's time to mate. And thyroxine is one of these main hormones that's important for this. And this also is thyroxine is important in the production of testosterone. So as you get warm through the spring into the summer and your thyroxine levels go up, and then they stay elevated. Once they reach that plateau of staying elevated, that's what tells those estivole, I believe it is, reproducers, all right, time to make sperm all summer long. If you don't have that cue with the thyroid and the hypothalamus, your snakes aren't going to be able to reproduce. So you need that. It's important. And so that's another thing. Another thing with light, everybody knows about melatonin. A lot of people take melatonin right before they go to bed. They're basically hypersaturating their brains with a hormone that they produce, which tells you all to go to sleep. Well, melatonin is directly, it's one of these biomolecules that's produced based off light hitting your retina. So when it's daytime, you got sunlight hitting your eyeball if you're a snake out in nature, and that's telling the production of melatonin in the body to stop. Whenever darkness hits, that's going to be telling the production of melatonin to occur for diurnal snakes, obviously. And it's very important for the maintenance of a diel period. And in biology, we use the word diel, D-I-E-L. That's simply referring to your 24-hour activity period. This is really cool because melatonin turns out is real important in the initiation of courtship behaviors. So we've talked a lot about hormones here, but we haven't really talked about behavior in the brain here. Melatonin has been shown in red-sided garter snakes in particular to be an increase of melatonin following brumation is what lets the boys know, coupled with everything else, but melatonin's critical in telling the snakes, go court something. Go find a female. And with the females, you get this increase of melatonin after an extremely long period of darkness, post-brumation. That's what tells them, I need to mate. And there's been some really cool studies done where you can the gland that is responsible for production of melatonin is the pineal gland, and you can basically ablate the pineal gland, which is kind of grisly, but you basically hit it with a soldering iron, not the nicest thing, or some other mechanism, and you eliminate it from the brain, so now you're not producing melatonin. And in studies where where this was done, the lack of melatonin following brumation, the lack of production of it, the snakes never got the message, I came out of brumation, it's time to mate. So once again, if you don't have this series of events occurring to tell the snakes, I'm going into brumation, I'm in brumation, I've come out of brumation, you're not going to get courtship behavior. And melatonin is one of these hormones that's super important for that. And melatonin's production is that's one of the reasons why you're going to be keeping your snakes in total darkness all the time. So I went so far this year, because I have one of my grad students' theses, we're looking at egg incubation in colubrids. So we need a butt ton of baby colubrids. So that's why My garage has over 80 colubrids in it right now, cooling down. But I knew about this, so I went and found solid black bins that locked, and that's my brumation bins. And then I've got blackout curtains wrapping the corner because I don't want it is absolutely overkill. I'll fully admit to that. But there's not a single photon hitting that corner of my garage when the lights are on, because this is why, to make sure that this happens.
Well, and it's very interesting too, because how important light is, but full spectral lighting sometimes gets ignored within a hobby. Even myself, I use full spectral lighting in all of my recessed lighting in the snake room. And it's such an important part of all this, because all of these visual cues, and we know this even from avian science too as well, with the study of birds, about how important full spectral lighting is.
100%. It's yeah. And if you think about it, especially at temperate latitudes, the tropics maybe not so much. At temperate latitude, the UV index changes with the seasons. So, yeah, let's just be real. I'm on team UVB for colubrids. I think it's important, and giving them that and having it increase through the spring, at a zenith over the summer, and then decreasing through the fall with photoperiod and everything else. That might be what's needed to get snakes to live a long time. And I hear a lot of people talk about like longevity in snakes and things like that. And it's not at all uncommon for kings and corns and things like that to reach the 10, 15 year range. But there's been studies done with these animals from nature that show once they reach a certain size, they're really good at surviving. And it's not at all uncommon for a lot of colubrids to make it 20, 30, even 40 years. Right now, we have a South Florida king snake, a Brooks king, that my friend bought at the All Ohio Reptile Show when I was a sophomore in college in 1999 as an adult. And that snake's still alive back there. And for about 10 years, I had it in a Viv. It was the only snake I had for a real long period of time. And just for the hell of it, I had a UV light on the damn thing. I don't know if the UV light's the reason why it lived so long. But I feel like, having these cues, shutting them down, turning them on, the right season, they evolved for that. So just mimicking that can only help them. But you also hear about people that talk about how they've kept their whatever alive for 25 years living in a rack system without any UV light. There's probably some other cue, though, that's mimicking this seasonal aspect of their biology, because I feel like just flat out denying a snake that it's going to shorten their life somehow. Their quality of life will be decreased, their lifespan will be decreased, but something is not going to be firing at all cylinders if we're not at least trying to mimic what's happening in nature, because that's where they evolved. They did not evolve to live in the box in our living room.
I think I'm just going to start juicing my snakes.
What was that?
I think I might just start juicing my snakes.
There you go. Yep. Yeah. So, no. So.
Hey, but real quick, I really should say, I have no plans of juicing my snakes before I get some email or message asking how I'm going about this. That was a joke.
Yeah, we need to be able to laugh, people. So, good things. All right. So that thyroxine production and the melatonin production, that's super important for the regulation of these hormone cascades in males. And I feel like one of the issues that you always hear people talking about females, but if your males aren't being cycled, you're not going to get eggs. I know for a fact. I don't know for a fact, but I moved on my beauty rat snakes. I had Taiwans and blue beauties because I kept getting infertile eggs, and I am 99% certain that my infertility was coming from my boys, not my girls, because the infertile eggs that came out were they were perfect. Like, I even kept a couple of them in the incubator, even though I didn't see veins, because I just had a really hard time accepting they were slugs. So the females were able to do their bit, but the boys weren't. And Japanese rat snakes, I didn't produce Japanese rat snakes until this year. I went 3 years without producing them. And last year was the year that I was like, all right, this is going to happen. And I had all their temperatures dialed in. I made sure there was a fall, even though we didn't have a fall in West Virginia. That's one of the things that drives me crazy is it's like summer, then winter, then summer, winter, summer, winter. During winter, it doesn't make any damn sense. But I made sure that those males were in complete darkness. I got them cold. Like they went down into the mid 40s. And I warmed them up slowly. And this was the year that I got my clutch. So something was going on there that was right.
Well, and that's something, a lot of people in terms of breeding or purchasing animals or reviewing animals, we ignore multiple males. We're always worried about having multiple females. And I'm of the take that I'd rather have more males because I actually want to increase my sperm production, which is aggressively charged by introducing multiple males into a female. Something we didn't talk about because there's not a lot in terms of publication off of that, but there is competition from males to males, especially when they're courting the same female. And that does lead to higher reproductive success with fertility because you're pushing out or pushing away the bad sperm for a male that likely had been cycled better in that sense.
And you're initiating those courtship behaviors. And we'll have another discussion about actual reproduction. I mean, this has a lot to do with reproduction, but this is like kind of focusing on the seasonal aspect of it. But in reading these various things I read, getting ready for tonight's episode, there was been a lot of really cool work, primarily with the garter snakes, that did show that if you had a single male and a single female, and you put those animals together, and then you looked at these various hormone levels and things of that nature, that the levels kind of plateaued. But if you put multiple males in with the female, like you're saying, not only did it cause like a massive spike of testosterone levels in the males, which then initiated in them a much stronger drive to mate, but the fact that there was so much mating activity going on with the female, that then caused a cascade of hormones in her that then led to almost guaranteed ovulation. And so that's definitely something to consider. I did this past year with Madagascarophis colubrinus, the Madagascar cat-eyed snakes. I had a female that was huge, and I have 2.2 of them, and I decided, what the hell? I had a yellow male, I had a brown, silver male is what they call them. Both of those are natural phenotypes, and I just put all three of them together because one male wasn't really getting it done, and then I put the other male in with the female, and it didn't get anything done. So I put them both in there, and holy mother of God, the tub was rocking. That's all I got to say. Because that, he realized, holy crap, there's another guy here, and then suddenly, those instincts, I think, kick in, and then you end up having eggs. You get a successful clutch, and I don't know if people do that enough. Obviously, if you're like breeding a line or you're trying to get a designated morph or something like that, you're not going to be doing that. But if you're in the business of getting natural phenotypes, that might be a way to go. Now, you have to be careful because some colubrids will combat like pythons. It's rare, but when it does happen, it's just as bad. So you got to be kind of careful on that front. But definitely getting that sperm competition is important. And then hard to species we're trying to get established. If you have multiple male paternity, which does happen a lot, oftentimes if you do breed multiple males to a female snake, the eggs that are laid will have multiple fathers. That is one way. If you are going to breed those animals from a clutch together, you do kind of have siblings then. You don't know if you have a half sibling necessarily, but that might be better than just breeding two sibs, pure sibs together. So, all right. So I think we made it through our outline. Is there anything on this outline before we just start talking about straight husbandry that
No,
we didn't hit
nothing.
on?
Yeah, nothing too crazy. I think, even from the questions we had, I think a number of them, they kind of pinpoint what are the extreme lows,
Yes.
if you will. Now, Zach, I don't know how low you've ever brought your collection down to, but I had my room one year go down to, I think it was about 15 degrees. And
Fahrenheit.
Fahrenheit. And it
Holy
froze
crap.
the pipes. It froze the pipes. And the animals themselves, and this is something that really goes into biomechanics, is you'll actually see the muscles twitch. And they're twitching because they're trying to warm their body to actually, heat up a little bit. But it's not necessarily getting them that cold, but what happens after you get the animals that cold, which is bringing the animals up.
Yeah.
And if a room gets that cold, or you're exposing those animals to that extreme cold, you have to be very cautious, because their immune system is then compromised because of the exposure to that. And that's even something in terms of even bringing animals out of brumation that you have to be careful with too. But I would say, and this is just from my personal care, is about 50 degrees Fahrenheit is as low as you really need to get these animals, especially multiple generations of captively reproduced animals. Once you drop below that 50 and you're holding those animals to that point, you're weakening their immune system, but you're also creating issues respiratorily for that animal. And it will show in that animal after bringing them out.
It's interesting. So I have in the corner, it will get occasionally down to about, my lows are around 46, 47. So it's not that far below 50, but it doesn't stay at that temperature.
Right.
There are some, like the species that live up, like northern taxa, like the red-sided garter snakes, their hibernacula routinely get into the mid-40s. But I think for most of our animals, you're spot on. 50 degrees is definitely the target. I try to hold my stuff between 48 as an absolute low and about 54, 55. And if I'm somewhere in that window, I'm happy. So we talked a little bit about govies. If you don't know what govies are by now, you definitely should look those things up. They're wonderful. They're these little Bluetooth temperature loggers, and they log humidity. What's absolutely crazy to me, being an ecologist, is they're the exact same thing in my field. It's called a hobo. That's a data logger, and those are much more expensive than a govie. And now that I use these govies, the interface of the govie and getting the damn data from the data logger from the govie to my phone is a hell of a lot easier than it is for these, for the professional hobos. And I've even thought about maybe we'll just buy a bunch of govies and throw them out in the field and just see what happens, because they're really nice. And they sell, or Govee has a couple that are, so there's different levels. There's a 3-pack. It's not that expensive. I don't know how much it is, but
I think they're like $12 or $14 a piece, I think.
Yeah, they're not too bad. Yeah. And that standard issue, you have to have your phone within Bluetooth range of the unit, and it'll load. And that's what I have literally all over my reptile collection at my house. But the first one I bought was somewhere between $25 and $35. And that one, I only have one of those. And it's right in the farthest corner where it gets the coldest. That unit is really cool because it communicates through Bluetooth to my my internet connection. And then when I can sit here at West Liberty or anywhere on the planet, if I have Wi-Fi, I can upload, tell it to talk to my router, and then it basically grabs the information off the unit and then dumps it onto my phone so I can check temperatures at any point in time. And by now I know that there's things that are more specific than the govies, but I really, really like them. But the cool thing about those, the interface, is that you can set a minimum temperature and a maximum temperature. It'll let you know with an alarm. The output that I get, I have it set at 47 as the low, and I think I have it at 55 as the high, and that's good. And if it drops below that temperature on the graph, it turns red, and if it's above that temperature, it turns red. So I'm able to like look at the past month and see like how long was I in that window. So I know like when we had that warm spell last week, you know, I was way outside the window for like 48 hours. But now that it's gotten cold again, I've been within my window. But that's a cool little thing as far as finding your temperatures and seeing where you're at. I highly, highly, highly recommend those things.
Same boat.
Mm-hmm.
And Govey, if you want to contact Zach or myself about...
There you go. Yeah, it's funny. I got them for my house, and I got them. I learned about them through, I don't know if it was a podcast or a Facebook group, and I bought the really fancy one first, and then I bought the not so fancy ones, and then realized these things are amazing. And I came up here, and for Zoo Science, I think I told Kinsey Guthrie's woman that's the assistant curator. I'm the curator, but I told her like I want to buy 30 of these. Like literally, I want them in every room. I want to be able to check temperatures at the top of the stack, the middle of the stack, the bottom of the stack, so we can actually kind of understand what the hell's going on. Because the science building we're in it's a thermal nightmare. That's also why all the snakes are at my house because I can control the temperatures there. But no, well worth getting, and it gives you massive peace of mind. Knowing, well, I guess it gives you peace of mind. It might freak you out, but you at least are going to know if you're hitting the temperature range you need to hit with these units. Because I don't think people realize how much temperatures change in a part of their house between day and night. Like, I get about a 5 to 8 degree temperature swing every day out in the garage right now.
Oh, yeah. I mean, even within the basement where I have mine, you'll see 5 to 6 degrees just in terms of a drop at night.
100% on that one. So I'm looking at our questions here. So Matt Rasmussen, and these are questions, by the way, I threw up on our Facebook page and asked what questions y'all wanted answered or discussed. He asked, what is the risk reward to brumation? Longevity, feeding response, overall health versus possible vulnerability to immune system, decreases metabolism, so on and so forth. So we've talked a lot about brumation in regards to reproduction because it's needed, but a lot of people, John talked about this with the Mountain Kings. Mm-hmm. You can also use brumation as a way to get feeders that are being a pain in the ass to eat. So have you ever done that?
I do, with Chinese mandarins and several other Asiatic species, just to trigger them, if you will. Mm-hmm. So there is definitely a benefit to it. And some people do a false brumation because, again, especially with difficult feeders, it's not a matter of bringing them all the way down, but trying to manipulate them enough so that it triggers a response inside of their endocrine system to actually start the process, if you will. Because for some of these animals, again, we're following what we think is the natural cycle, not necessarily what these animals are encountering in the wild. And that's why one of my statements at the very beginning was, as you get multiple captive generations of the animals, things do change a bit in terms of difficult feeders, cycling those hatchlings that are difficult feeders through a brumation period. But there is a big reward with that in terms of overall health, just because all of those hormones that are triggering and going through that animal's body are an important part for natural stability within that animal's operation, if you will. It's very similar to humans, controlling those different hormone levels. And really, that's the reward here. We want to make sure that the animal is cycled properly. But also, in terms of that, you do see longevity on the animal, because that animal being cycled properly is going through these processes not only in terms of burning fat, burning calories during the cycle when it's active, but also building up those natural chemicals for its overall life.
Yeah, I for a lot of these guys, giving them the winter off, cooling them down a little bit, not feeding them. We always talk about obesity with snakes and things like that. This is, you're literally, I mean, if you think about what's going on, if we go back to that definition, they're basically physiologically taking a break. That's another way to look at it. And if you're kind of working at your operative state and you evolve to have a break in your 12-month cycle and you just keep trucking at full speed, you're going to wear the machine out sooner than it needs to be worn out. So there's nothing wrong, I think, if you're not breeding, if you're just keeping the things, just shut them down. So here at a lot of zoos do this. A lot of breeders do this. We always joke about how it gives us a break and it's easy on the food bill and all that. That's another reason to do it. Is that you might need a break. But as far as the snakes are concerned, I don't really see a problem as long as you're reaching the temperatures needed to actually induce brumation. We're not saying that you just decrease temperatures, because we talked about if you're keeping your animal at 80 degrees and you get it down to like 65, 60, that you might still have it at an operative physiological temperature, and in that situation, yeah, you got a problem. You know, you're basically holding it right at that temperature where things are starting to work physiologically, but they're not able to reach their highest point, and your immune system is going to be impacted if you're maintaining the animal there all the time. But that's if the animal's operative temperatures are in the 80s. A lot of the Asiatic rat snakes that you keep, 60 to 70 degrees is where they want to be. Like, that is the operative temperature. So this is where understanding the biology of your snake matters. And then another thing that I want to talk a little bit about is where the animals come from and where their genes originated. That's kind of an interesting aspect of brumation. So think about corn snakes right now. There are currently corn snakes in Florida. Florida is warm as hell right now. It's where a lot of us up here in the Great White North wish we were. And those corn snakes that are in Florida right now are feeding, eating, doing what they're going to do. The corn snakes that are 3 hours east of me in the panhandle of West Virginia, same species, different latitude, they're hibernating right now. So where the stock of your animals comes from within its distribution, that's important too. Bull snakes, Jen talked about this when we had her on. The Kankakees that are in northern Illinois and northern Indiana, they have to have a very different physiology than the bull snakes that are slithering around Corpus Christi, Texas right now. So this locale-specific stuff, you know, you might have to brumate a kank a little different for success than you would an Amarillo bull. Or you may not. This is the fun part of herpetoculture. But I would, if you're kind of getting into this and you're trying to maximize success, I would totally go, you know, and make sure that I'm cooling down my kanks colder than I would be the Kankakees, the colder than I would be cooling down the Amarillos. Jesus, it's hard to say. So, you know, and that's the fun part of herpetoculture in my mind's eye, is like understanding all these little nuances that occur across the species range with these different races we keep.
Well, and everyone likes to talk about localities, but this is really where locality serves a bigger picture, because there's so much that can be found just off weather.com or your weather app off your phone by just putting in those locales of the animals, because you're able to paint a bigger picture of what's actually going on in that animal's natural home range.
Yep. WeatherSpark. I put it in that paper I published. Everybody should go to WeatherSpark. WeatherSpark's an amazing website because they take all this really complicated climactic data, they present it in across the calendar year, and they literally have, like, their variables are pleasant to miserable. Like, those are the climactic variables are showing. Like, I'm going to Costa Rica. We were supposed to go in January with all this Omicron BS that's happening. I just thought it would be safer to push that trip back for one of the grad students. So we're going in April. And when I looked up the Osa Peninsula where we're going, we went from the pleasant category to miserable when we moved our trip to April. I was like, son of a bitch. Anyway, but I don't know. Blacktail Crebos are there where we're going, and that's my target when we get there. More on that later. But go to WeatherSpark, and if you're trying to figure out what your temperatures need to be, that's a good way to look at it. And I'm not talking about, like, if the low's 5, obviously we don't get our bull snake down to 5 degrees. But if you're trying to figure out how long the brumation period should be, that's cool. So I guess we should talk about the classic recipe for brumation, because I was taught that you go by holidays. So let me get this straight. Halloween, you start dropping temps and cooling and cleaning everybody out. And that gets you to Thanksgiving. And Thanksgiving, things go down. So sometime between Halloween and Thanksgiving is when you're going to be dropping everybody down. And then you go from Thanksgiving to Valentine's Day is when the full-blown brumation's going on. And then in Valentine's Day, you start warming up. And then you start pairing things late February through April. If it's a classic temperate colubrid. There are colubrids, don't follow this at all. You got fall breeders like indigos, where right now you're putting your dry marking together, or if you're just getting to it now, you might be a little late. You start about 2-3 weeks ago, or hell, when we bred yellowtail crebos here, we did it all through October, November. So not all of them follow that, but if you're literally cooling, that's kind of the recipe, and you got to clean them out before you put them down. That's the other thing. If you feed and then put a snake into brumation, that's kind of a death sentence. You don't really want to do that. Because we talked about this. You're shutting down the digestive enzymes. And when you shut those down, that rat is going to rot and putrefy in the gut. And we just don't want that to happen. That's not good for anything. Do you follow that recipe, or do you do something different?
So I've had to adapt a bit, and part of that has to do with the way the weather in the Midwest has been over the last couple of years. So I try to follow what is actually going on. Mm-hmm. So when weather starts to drop, which is typically now, we're starting to see it drop in November. Typically in November, I pull everything, and I'll keep feeding if the animals are still active, because it's not until December, which is where we're starting to see a majority of our temperatures drop now. And from my perspective, you really only need 2 to 3 months for those mm-hmm. animals to go through cooling. It's just enough just to trigger them so that they can go through this cycle. But with that being said, what I'll do is watch what's actually happening in our barometric pressure, temperatures, and cycle off of that. Because I think those are some of the bigger cues that will transpire to those animals. Even though they're in our basement, or bedrooms, or offices, they're still going to respond naturally to those pressure changes.
That's really interesting. Now, I've been fortunate here in West Virginia that kind of classic time period, the temperatures are for the most part where they need to be for those benchmarks to occur. What's been really weird here in the Mid-Atlantic where I'm at is that we don't have a fall anymore. Our transitional seasons are not happening. And on the subject of climate change, that's what many of the climatologists predicted would be the effect for the whole Arctic, the temperate part of the world where we're at, is that you would lose transitional seasons and you would get an extension of your primary seasons being summer and winter. And that is essentially exactly what is happening here. And it's really freaking annoying because, I remember growing up in the 80s and the 90s that I would play flag football back in the day, or I played football in 7th, 8th grade, and then it was like, screw that, nerd time, band, and went to the band for high school. But anyway, I remember being in practice, and I distinctly remember October was cold. Like,
Yeah.
Once it got to be evening, I had on my hooded sweatshirt and my sweatpants, and I'm running around outside. And by the time Thanksgiving came, there was snow. And then December, January, February, March was cold. And where I'm at, for like 5 consecutive years in the late 80s, early 90s, it snowed on Easter. So like that was the old, and just in my lifetime, which has not been that long, now we're catching queen snakes with our queen snake study in frickin' November. Like that's unheard of. And I'm 100% certain last week when we had the 70-degree temperature, if we knew where the damn hibernacula was, which we will know where that is for that population this time next year because we're going to be putting transmitters in them. If we would have been able to go to that space, we would have almost certainly been seeing snakes laying out basking, because I saw all kinds of pictures on field herping pages last week with the warm spell of like, what the hell is happening? And there were snakes basking in places like Vermont and like not mid-Atlantic, like where it should be cold right now. So that's likely going to have some kind of effect on the reproduction of these wild animals. And we're going to see it in our captive collections, because if the things don't get cold, we don't get that much breeding. Now, we do get those one-offs, and this is where selective breeding gets kind of interesting, because you do have variation in a population. There are absolutely going to be animals in a population that might have these hormone cascades happen at warmer temperatures, and they might have these hormone cascades happen with more light. And if we're breeding, somebody has an off, like, breeders 1 through 6 don't get any offspring, but breeder 7, who's in the mid-Atlantic, does get a clutch. If you think about it, those animals almost certainly had the gene, had some kind of slight mutation or some kind of epigenetic effect or something that made them go that year. That could be passed on to their offspring, and then that's getting to what you're saying, where it might be in future years where people are like, well, why the hell did they talk about brumation? We don't have to really do that. Well, you did back then. Like right now you do, but we're selecting the animals that have the least response to it, and that's how you end up with the random pair of corn snakes that breeds in someone's living room and you didn't drop them down to 55 degrees. So, there's a lot going on here that we don't even think about, that's from a biological perspective pretty damn fascinating. And that's one of it.
So I think our Valentine's episode should be breeding.
There you go. Yep, that worked. Okay. Looking at... Oh, and then the other question is, do snakes actually drink water while in hibernation in the wild? I have no clue. I haven't read any papers that say that one way or the other. I don't think I've seen a snake drinking during brumation, but I don't see why some of them wouldn't.
Yeah, I've had snakes drink during this period. I think the biggest thing with water is you have to understand that the body is still, the fecal matter, the urates, those functionalities are still going. They're not completely shut down. So if the question is, should I offer water during brumation? I think the question should be yes.
Yes.
Because you need to have that available resource for that animal.
Yeah. And I had something interesting happen along that same lines of like the kind of classic conditions that are going on inside a snake slowing way down. So I've kind of talked about it, but I haven't really discussed it in depth. But beginning in July, I jumped off a Florida king snake cliff that was much more massive than I realized until I was putting them away, and they're being brumated too. And my largest, prettiest Brooks male, Brooks Eye. Yes, I know we don't honor that, but in herpetoculture we do. So, he's just a perfect example. Right when I was boxing up everybody to go to the corner, I pulled his tub, and he was just starting a shed cycle. Okay. Normally, because I keep records, and I've dealt with this. That was today. No, it was yesterday. Sorry. Normally, it takes that snake 8 days to go from starting to cloud over to ecdysis, shedding. That's very typical for him. He started that the week before Thanksgiving, and I have all the heat off all the snakes. He's not in the corner yet, but the part of the room he's in is about 60 degrees, 65 degrees. And I checked on him yesterday, and I've been trying, as soon as he sheds, he's going to the corner. And he actually cleared up and just didn't shed. So yesterday I peeled him, but he would have probably maintained that. If I would have put him in the box and shoved him in the corner, he would have probably shed coming out of brumation. I mean, I don't know. Although last year I did have a hognose snake shed in the middle of brumation, which was really kind of interesting. So, they do things like that, but a lot of these normal activities slow way, way, way down. I was able to help him shed yesterday, and he is now in the corner with the rest of the Brookside. So, anyway, but yeah, that's a part of this that's important. So, brumation checks, you should definitely check them. You don't know what the hell's going to go on. I'm not ashamed to say this because everybody has this happen if they have large collections. Here at the university, we had what we're referring to as mite-ageddon. It's not just like a small mite flare up, but we don't know how the hell we got him into our snake lab, but mites came in and we basically nuked that space, and the mites have been dealt with. But I'm terrified that I was boxing these things up, and I don't know if I transferred a mite or two to them. The mites are going to be slowed down with brumation, but they're not going to be stopped. So doing a welfare check, I'm doing it tomorrow to see did anybody get mites while I was boxing them up. You can also, if you got too much moisture in there for some colubrids, you're kind of begging for respiratory infection maybe, or fungal infection. So you want to make sure it's dry. This year I went to a bedding. I don't know if it's going to be great in the end. I like it so far. It was real cheap, but I used corn cob bedding. So I basically beat the hell out of it, got the dust away, and then I wanted it to be as dry as it could be. Obviously, if they spill a water bowl, that's going to hold on to moisture, but most substrates will. But I'm going to check for that. And we're just going to make sure everybody's okay. And I don't want to disturb them because the whole point is to kind of reach a homeostatic state. So I go basically once every 2.5 to 3 weeks. I just pop my head in there, make sure everything's okay. I'm a little bit worried because they warmed up with the warm spell. That's part of the reason why I'm checking on them. They might have passed some urates or got a little bit more active than normal and knocked over a water bowl. But I don't disturb them much, but I am checking them. It's not like it's put them away and check them 3 months from now. Is that pretty much what you do?
Well, so I think I'm a little more intrusive. Several years ago, I had an animal develop a bacteria infection in the mouth because the animal had expelled its feces in the water. And I was actually gone for 2 or 3 weeks at that point, so I didn't catch it in time. So now I'm very paranoid about things like that. So I'll actually go in and change water bowls every Saturday, even on.
Oh, wow.
Well, you get burned once, right? And
Yep. Mm-hmm.
But it's not going in there and moving the animal or disturbing the animal. It's going in and getting the waters done, replaced, and then moving on. So, and then typically once a month I'll just check on the animal because typically they're underneath their hide and things of that nature just to make sure the animal's welfare is doing well. But I am fairly anal on the water bowls after that instance. So
I haven't been burned yet, but if I open those tubs up and somebody has a mouth infection from a water bowl, I'll be right there with you, man.
Yeah. It happens.
Yep. So here's a question. Do you Brewmate anything communally, or is everybody in their own tub?
Right now, everyone is in their own tub, or cage for that respect. I have in the past done Arcalafe and Prasinum, the green bush rats. The green bush rats typically at sexual maturity are housed in pairs year round. So, and that's one of the more interesting parts is you do see that breeding behavior throughout the winter and fall.
That's pretty cool.
So you'll see some of that. That's why you start to see these developments where these animals probably do have some subset of either or for the way their sperm is developed and the way that the animals are breeding to maximize success too as well.
I have we did a massive check for crypto, Giardia, various viruses in the collection here at the school right before everybody went down for Brumation. We did the entire collection, multiple tests. So I knew that the animals were clean. And just for the hell of it, this year I am brumating our bull snakes, and we have a large corn snake colony. And if I gave every corn snake its own tub, my wife would murder me because I said there's like 75 snakes down there, but there's probably only about 30 tubs because all the male corns are together in a great big tub. All the females are together in a great big tub. The pitchophis are together in a great big tub. And then because I had the Japanese rat snakes together, I'm trying something this year just for the hell of it, which is they're all brumating together. And the reason for that was I was thinking about in nature, a lot of times you have these communal hibernacula, and I was just wondering if there's something there. And this came from me researching for this podcast, because there is evidence with the red-sided garter snakes that the communality of the hibernacula is also a major important driver for the production of reproductive hormones and receptivity coming out and of brumation and hibernation and all that jazz. So I thought it would be kind of cool to just see what the hell happens. But that's the one thing I did different this year.
Well, and there are several people, more senior members of the hobby that do keep animals in communal settings for this process. And they always have great success with their animals coming out.
Yeah. But all those king snakes have their own tub. So many individual king snakes. That's when I realized, like, I may have a problem. Because when you look at, there's these big roughneck tubs and everything, and then there's just 16 quart black tubs, like, stacked 3 tall. I think I got, there's over 20 of those. And almost all of them. But there's some hognose snakes in there. There's some, a couple individual corns, the subocularis, the Transpecos rat snakes I have are in those. And then just king snake, king snake, king snake, king snake, king snake. So, anyway, the worst, I would have loved, if I would have done the communal, it would have been very interesting to check on this Brumation check and found, one had eaten one halfway, then it got cold. I don't want to deal with that.
Yeah, so, right.
Anyway.
Oh, man.
Okay.
Well, I think we clicked on everyone's questions in some shape or form throughout this whole process.
Yep.
But yeah.
Anything else? I think we did it.
I think we're good. Hopefully we didn't... we provided everyone with good education on this because I'm sure some of this is very new to our viewer audience.
Yeah. So this is important. If you made it to this point, let us know if you like this or not. Because if you like these kind of more biology of keeping episodes, we'll do more of them. If you're like, good God in hell, why did you do this? And you found it to be boring, because I don't know if you, I love this stuff. Matt loves this stuff. I'm assuming that many of you love this stuff, but I don't know. But it is our podcast, and we decided to do something a little different. But please let us know if you didn't like it, or if there was something we didn't talk about that you'd like us to hit on, or some kind of broad topic, or pulling it into husband. We just want to hear your feedback. Any feedback. So you can get a hold of us through our various Instagram and Facebook handles as individuals. I'm Dr. Crawdad on Instagram, and then I'm Zach Loafman on Facebook. So I check Messenger all the time. That's how I communicate with my graduate students. So I am literally looking at that probably once every 2 to 3 hours if I have Wi-Fi availability. And then I made a Instagram page. I got to get Matt access for that as well, called Colubrid and Colubroid Radio. So if you're on Instagram, you can message us there. It has, as of this moment, 2 posts. So we're not very active there, but we'll put a link for this there. And then there's also Colubrid and Colubroid Radio on Facebook, where you can message us. And a couple people have reached out. Well, actually, more than a couple. We've been reached out to there. But we love the feedback, because this is still kind of it is in its infancy. And we took a gamble here, and we want to know if it was worth doing. So that's where you can reach me. Where can they reach you, Matt?
You can reach me through Sarpamitra on Instagram and on Facebook. And obviously, you can always email me too as well at matt@sarpamitra.com.
Yeah. So this is going to be our last episode for 2022. We made it to 8. We were rocking and rolling there when we started, and then this little thing called life showed up and kind of slowed us down a little bit. But we got great plans for 2022. We're only going to be going up. So with that, happy holidays, Merry Christmas, Happy Hanukkah, Kwanzaa, whatever you do. Dance around the maypole. We're here, and we're happy that the year's come to an end, and I think we're pretty happy with where we are with the podcast. So that's what I have. Anything you want to say there, Matt, as this is our last episode of 2022?
Well, we made it.
Yes. Or sorry, it's our last episode of 2021, not 2022.
Yeah. No, we really do appreciate everyone listening and following. It's been a great experience, and we're looking forward to it in 2022.
Yep. So that's that. Have a great one. Later.